Hello guys, welcome back to my YouTube channel. My name is Mike Matthew KE and this is my Logic in Programming series. So, as I promised, we will start our Logic in Programming series with the Fibonacci sequence. I already did a Fibonacci sequence video, you can check it up in the link there. And this time we'll do it a bit differently where we'll not use loops, okay? So I know somebody may be thinking, how can you do a Fibonacci sequence without using loops? Well, right off the bat, in my mind, there are two possible solutions. One of them not very optimal, where you can have a predefined array of the Fibonacci sequence, and then from there you only pick and choose up to the number that you need. However, the problem with that is you do not know how the Fibonacci sequence is a very long sequence. It is not ending, which means you cannot encompass every single value of the Fibonacci sequence in one array, or maybe you can, yes, but it will be very tedious and it's not really a well established solution to the issue. The other solution that I have is just using functions. So how will you use only functions to do the Fibonacci sequence? Well, we'll use a concept called recursive functions, which is basically a function that calls itself. So as usual, we'll be using C++ and Python. And on the video below, you can see that I've put markers. So in case you're only interested in one section, you can skip to the Python or the C++, or if I'd recommend that you see both so that you can see the contrast between the high level and the low level languages. With that, let's dive right into the code. So we'll start off with C++. So in C++, we have, first of all, we'll be using something called dynamic array, and dynamic arrays in C++ are called vector. So that's why I've put this. I've hashtag include vector. This is basically importing the library that contains that vector class. Then here, just to show an example of what vector looks like, so you declare std vector, then you'd put your type. So this is the type that will be contained within the array. So remember, an array should contain a specific type. Then next here, let's call it R for array, and then we initialize it as empty. Then from here, we'll also, in order to add values, we'll use array.pushback, and then now you put the value that you have. So for example, array.pushback 0, array.pushback 1, and so on and so forth. And then when it comes to printing, we'll do we'll just do for I in int I equals 0, then I less than array.size, we'll do I plus plus, and then now we'll see out the values at index. All right, same way we usually use with the static arrays that we're used to. Okay, so if I run this, you'll see you have 0 and 1 printed out. Okay, so that's the dynamic arrays in C++. I know for our users, we hadn't done that before. That's why I've introduced it. So let's get into the meat of our question, which is doing the Fibonacci sequence without using a loop. So in this, we'll of course start with defining our function. So first of all, I would like this function to be returning the array, which will be dynamically allocated. So we have this array, std vector int, that will be a return type, and then now we define the name of the function, which will be Fibonacci. So that will be what we will return. So for the parameters here, I expect that the user will give us the max count. That is how many numbers far into the series are we going to go. So for example, if we are going 5 numbers, we expect that the series will only have 5 numbers. And then in this case, I will also have a vector. Okay, so so here we have this vector which will be our actual Fibonacci sequence. okay, and I'll initialize it as an empty vector. Okay, so for a recursive function to work, we'll need this. I'll just keep doing the example and then we'll see why. So here, our first thing that we'll do is first we'll check whether our Fibonacci sequence, the size of our Fibonacci sequence is equal to our max count. And if it is, we'll return the value of this Fibonacci sequence, right? So that's the first step. The second step is if we have an empty vector here, so we'll just do if this Fibonacci sequence is empty, so at least we have a function that can allow us to check whether it's empty. Then what we do, we initialize our Fibonacci sequence by giving it by pushing back the value 0 first, and then we now push back again the value of 1, right? Then after this, now we'll check if it is not empty, that means it has some values. So what do we do in this case? Remember, our Fibonacci sequence is a series where each number is an addition of the previous two numbers, right? So what we need to do here is to have our next value. So our next value, which is an integer, be a sum of the last two values of the Fibonacci sequence. And how do we get the last two values of the Fibonacci sequence? Well, we already have an array that has all the values, so we just need to get the last two indexes. And the only way you can get the last two indexes dynamically is by getting the size of the array minus 1, because you remember the indexes start from 0, while the size will count the actual number of elements. So while we are at index 0, that is the first element. While we are at index 1, that is the second element, and so on and so forth. So here, when we're doing this, we'll have to get the Fibonacci sequence, and then we get the value at Fibonacci sequence dot size minus 1 plus the value at Fibonacci sequence dot size minus 2. So here, if you're unable to understand, so we have this is an expression its own. So we have this Fibonacci sequence, which is our array, and then we're defining the size of it, which we are getting the size of the Fibonacci sequence minus 1. That will get us the last value. And then this here, we get the Fibonacci sequence at its size minus 2, which will get us the second last value. And then in order to grow our Fibonacci sequence, we'll just push back this value of next into our Fibonacci sequence. So now we have an array that can grow according to its size, okay? And then the last thing we need to do is to return the Fibonacci sequence. But remember here, we need to return the whole Fibonacci sequence up to the max count, okay? It's not just at the first evaluation. If we return at this point here, if we return the Fibonacci sequence at this point here, so I'll just come here and set this up. We have an array which will take Fibonacci up to, let's say, the 5th term, for example. So I'll just leave this to print. If I run this, you'll see that we'll get only the first two values. Why? Because when we first evaluate this function, we'll only, first of all, we check if the size is equals to max count, which will be false. And then if we check the first value that we'll actually check, we'll see that the Fibonacci sequence is empty, right? So we'll push back 0, we'll push back 1, and then we'll return that Fibonacci sequence, which means we'll not get the full range of our Fibonacci sequence. However, if we call this function itself the Fibonacci sequence, and then we pass the max count, now becomes the same. It does the max count will remain the same, and then we now pass the updated Fibonacci sequence. That means that this function, that at this point it will go to this function, then evaluate again until we reach this point where the Fibonacci sequence at max count is the size of the Fibonacci sequence array is equals to the max count. So if I run this, you'll see that we get our value. So we have 0, 1, 1, 2, and 3. So we can see 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, and you can see that we also have 5 values, which means we have achieved our goal. So this is what we mean by recursive functions. It basically means the function calls itself. And now you can also see why we needed to pass this array here. We needed to pass this array so that we can always get the value being appended onto this array. So we can get the updated array and then add values, and then that's what will still output. So this is kind of the updated version of it. The other thing we can also do, we can make this a constant. The max count is constant, it does not change. So we can also make this max count. So let's try to take this a bit logically, right? So let's say, for example, we had given our max count as 3, or let's say 4. Our max count is 4, for example. So at this point, we've called our function the first time. So this is on our first function call, and we'll have our Fibonacci sequence will be empty, of course, and then our max count will be 4. So here, if we check whether the size of the array is equals to the max count, of course we'll get no, it is not. And then if we check if the size of our array is 0, which is basically if it is empty, then which is true, that means we'll push back 0 and 1. So which means we'll not evaluate the else here. So at this stage, at our first iteration, we'll have our Fibonacci sequence as 0 and 1. Then we call the Fibonacci sequence again, which means we'll have our second iteration here. So our second iteration will have 0 and 1 already as before. That's why we are passing it at this point. And then we'll evaluate, is the size equals to the max count? No, we have only 2 values, right? Is the array empty? No, it is not, which means we'll evaluate to else, where we'll calculate the next value, which is only the sum of the last 2 values, right? So here, we'll push back that last value. So on our second iteration, our result will be 0, 1, and then 1, because 0 plus 1 is 1. And then now we call Fibonacci function again. So on our third call, here, we already have 0, 1, and 1. And then we check, is our size equals to the max count? No, because we only have 3 values in our array. So this condition will not be true. And then we check whether it's empty. Of course, this condition is not true, which means we'll evaluate to else. So else, we'll just calculate the sum of the last 2 values, which will go to here. We'll have 0, 1, 1, and then 2. So you can see here, we've added the last 2 values and gotten the 2. And then we'll call Fibonacci again. So here, we have our 4th iteration, which will just take, we'll have our 2 added here, and then I will check, is the size equals to the max count? Yes, that's true. We already have 4 values, which is our max count. And then we return now the Fibonacci sequence. Since we've reached our max count, we return a Fibonacci sequence. So you can see this is exactly what will be returned. So if we do 4, you'll see that you'll have 0, 1, 1, and 2. If I run this, you can see 0, 1, 1, and then 2. So that's how the recursive function works. Another way you can modify this function, for example, you can choose to have this function not return anything. you can choose it to be a void function. And then here, if it's void, then you'll just return, right? But here we can choose to have this be an array that is passed by reference. Okay, an array that is passed by reference. And then if it's an array that is passed by reference, here in our vector here, we can choose to have, we can declare the empty array, right? And then now we call our Fibonacci function with our max count, which is 4, and then we pass the array there. So remember, when you pass by reference, it means that this value will be modified within the function. So if we pass it this way, we'll still expect to get the same results. If I run this, you'll see that we still have a 0, 1, 1, and 2. Since this is passed by reference here, it means that we'll be modifying the value of our array here. Okay, so that's another way that we can implement it. So in this case where we have our pass by reference, then we do not need to have this return statement here, right? We do not need to have this return statement since we'll be updating our Fibonacci sequence as we go along. So even if the Fibonacci will be called over and over again, we do not need to return. We do not need to have this return statement here in order for this to evaluate. So if I run this, you'll see that we'll still have our Fibonacci sequence printed out correctly. However, if we are doing it the way we had it before, so allow me to just Control Z a couple of times here. So we are at this point where we still have, we're still iterating through we're going through each function. You can see that we have a return statement here, and we are not passing by reference. We are passing by value. That's why we do not have the ampersand here. So in this case, we do need to have this return statement because that's what will give us our return value. If we do not have this return statement, then on our first iteration, where we have our empty here, and then we'll have this, at the end of it, we'll have this 0 and 1, you can see that we're not returning anything, right? We're not returning anything on our first iteration. That means that will not be conforming to this, which means we'll not be conforming to this return type, which is the vector of integers, which means we'll have an error. So if I run this, you can see that immediately an error pops by, which means read access validation and all that. Basically just means we are trying to access a null value. So it's basically like we're returning null here, which you are trying to assign to a vector of integers, right? Which is incorrect, right? So make sure whenever you're passing by value here, whenever you're doing these recursive functions, that your recursive function, whenever you're calling the function, again, you have your return statement, which means whatever iterations we have, whatever iterations will happen when you're calling this Fibonacci here, will still return our value. So always make sure you have that. So let's have a look at this in Python. So in Python, the concept will remain the same. We still have our Fibonacci sequence. We remember that in Python we have, when we have our array as a list, when we have an empty array as such, we can append to it. Let's say we append like so, and we append, let's say 1, for example, and then when it comes to printing, we'll do for, so we can do for value in array, and then print value, right? Which should basically go through each value of the array. And if you run this, you can see that we have 0 and 1. So that's just a recap of what arrays do. Now, when defining our functions, we'll define a Fibonacci function here. So we expect it to return a list of integers, right? So here I'll just pass. So the first thing we'll pass, of course, like we've done in C++, is the max count, which is an integer, right? And then next we'll pass a list of integers, which we'll call it a Fibonacci sequence, which is our list of integers. Okay. So the first thing we'll do here is we'll check if our max count is equals to the size of the Fibonacci sequence list that we have passed here. Okay. If it doesn't make any sense at the moment, I'll be explaining that better. So if the length of the Fibonacci sequence is equal to max count, then we should return the Fibonacci sequence, right? The other condition we'll have here is if our Fibonacci sequence is empty, or if it does not have any values. So basically, if it evaluates to 0, then that means we need to start appending the initial values of our Fibonacci sequence, which are 0 and 1. So we'll have Fibonacci sequence.append 0, and then we'll have Fibonacci sequence.append 1. So if our Fibonacci sequence already has values, then all we'll do is add the last two values, right? If it is not empty, or if its size is not 0, then we'll only append the last two values. So our next value, which is an integer, will be the sum of the last two values of the array, which is Fibonacci sequence at -1 plus Fibonacci sequence at -2 here, right? So those are the last two values of the Fibonacci sequence. And then the last thing that we'll do here, of course, is append this to this next value to our Fibonacci sequence. So at this point, at the end of this, if we return the Fibonacci sequence at this point, we'll of course not get what we need. So I'll just show that in example. So if let's say we say array is equals to, here I'll just make sure this is initialized to an empty list first of all, and then here we can be able to call array equals Fibonacci, where we'll give a max count of 5, right? So if I run this, you'll see that this will evaluate to 0 and 1 only. Why? Because we are only evaluating this function once, right? So that means of course this first condition will not be true, and then we'll find that the condition that the size of the Fibonacci sequence is 0 is equals to true. So it will append 0 and 1, and that's why when we return, we'll only get 0 and 1. However, if we want to get the full sequence, then we'll have to call the function again. And we'll still be passing the max count. And then here, instead of passing the empty array that we passed in the first time, then we'll pass the Fibonacci sequence that we have here, that we've already appended our 0 and 1. So this we'll expect to evaluate until we get the actual values that we're looking for. So if I run this, you'll see that we'll have 0, 1, 1, 2, and 3, which is our Fibonacci sequence. So we have first of all, we have our max count. We see our max count was 5 here. So you can see that we have 5 values, and you can also see that each value is the sum of the last two. So you have our initial value 0 and 1, and then 1 plus 1 is 2, 1 plus 2 is 3. So you might ask, how does this work? So like we've looked at it in C++, it's the same way that it works here. So we'll just do the iterations. So for the first iteration here, we had an empty array, right? That was our first iteration. We had an empty array, which means when we evaluate it here, the length of a Fibonacci sequence will be 0, and the max count is still, let's use the example of max count equals 4, right? So can see that 0 is not equals to 4, which means it will not return at this point. Then we'll check if the length of the Fibonacci sequence is 0, which will be true. So that means it will append 0 and 1, and the else condition will not be evaluated, which means at this point, at the end of this function, in our first iteration, we'll have our list as 0 and 1. Then you can see here, we call the Fibonacci function again. Instead of returning, we return a Fibonacci function, which means it will still call this Fibonacci function. So when it comes to this, we'll go to our second iteration. Our second iteration already has 0 and 1. Then we check the size of this Fibonacci sequence, which we've passed here. We'll see that the size is 2, which is not equals to our max count, which is 4, which means this will not be evaluated. Then we check whether the size of the Fibonacci sequence is equals to 0, which is of course not true, which means we'll come to this else evaluation, which will take our integer here, which will be the sum of the last two integers, and then appends it to our Fibonacci sequence list. So we'll have here a sum of 0 and 1, which is 1. So in our second iteration, at the end of it, we'll still have 0, 1, and 1. And then you can see we are still returning our Fibonacci sequence, right? So when we call this Fibonacci sequence, we'll be getting our third iteration here, which we already have 0, 1, and 1, right? Then we'll go into checking whether the length of the Fibonacci sequence is equals to max count. We'll get that the size is 3, which means it's not true. Of course, it's not empty, which means we'll evaluate this again. So we'll come into our next value here, which means we'll evaluate the sum of the last two, which will have 2. Again, the function tries to return the Fibonacci while evaluating the Fibonacci sequence again, which means we'll have our fourth iteration, which already has 0, 1, 1, and 2. Then we'll evaluate, is the Fibonacci sequence, the size of the array that we've given, equal to the max count? It is, right? Since we have 4 values here. So which means it will evaluate and return this Fibonacci sequence. So we expect to get 0, 1, 1, and 2. So if I run this with our max count of 4, you can see that our result is 0, 1, 1, and 2. Another thing you need to be careful with here, whenever you're calling the function again within itself, you need to have the return statement. So for example, I can just show you in Python here, you can see that whenever we're calling this Fibonacci again, we have our return statement here. That means we are reaching the end block of our Fibonacci sequence. If you do not have this return function here, then we will not get the value that you're expecting. You can see that it already raises an error since we have none. We're not returning just fails. We must have our return here. Okay, so you must make sure that you have the return, because if you don't have the return here, what happens is on our first iteration, we'll come here. So you can see we have not evaluated our size is not the max count, which means we'll not return at this point. So all we've done is we've appended the Fibonacci sequence here, and then at this stage we'll still have our 0 and 1 in the first iteration. But since we are not returning anything, it's the same as returning null, right? Which means at this stage we'll have none, right? Since here we've not returned anything, it's the same as returning none, which means we'll only return none. And that's why we have this error when we run here. We'll see that we are trying to do a loop on a none value, a none type value, which means it fails at this point because you cannot loop through a null value, right? So that's why we have that error right there. I hope you've gotten to learn a new way of doing things with the recursive functions, as well as a new approach to doing the Fibonacci sequence. So like I said before, when it comes to programming, it's up to you as the programmer to approach the problem with a solution that is best fit for your scenario, right? There's always a couple of solutions that you can have, but sometimes some are not optimal, sometimes some are not compatible with whatever program you're making. So it's up to you as a programmer to gauge which is the best approach that can apply to my situation, right? So if you've enjoyed this lesson, please share, like, and subscribe. And also please share on the comments in case there are certain problems that you'd like to look at in terms of logic. How can you approach some things logically? Please share. I've also put my email on the description below so that you can be able to follow up and I can be able to look at such problems. Remember, we'll be doing simple problems such as this, looking at different approaches so that we can also broaden our minds as programmers. How can we approach different problems? So I hope to see you next time.